Hello students, today I am going to teach the unit 3 of mathematics 2 course. And now Fourier series, these are the tools for representing any periodic function in the terms of infinite series of cosines and sines. Now what do you mean by periodic function? A function f is said to be periodic if f of t plus p is equal to f of t, where this p is the period of this function, means graph of such function is repeated after p. The smallest positive period is often called fundamental period or primitive period. Means f of x plus p is fx, and here the value of p is the smallest positive number for which this condition holds. For example, f of x is sine x. We know that f of x plus 2 and pi is again f of x, right? Where n is plus minus 1, plus minus 2, plus minus 3, even 0 also, right? But fundamental period is what? It is 2 pi, because 2 pi is the smallest positive value of p, for which f of x plus p is again f of x. We have another example. F of x is constant. Here f of x plus any real number is again f of x. So every real number is the period of this function f of x. So we cannot find smallest positive number in this case. So this function have no fundamental period. Now, if f of x has period p, then f of ax has period p by a. For example, if we consider fx to be sine 2x, then the primitive period in this case will be pi, right? Sine 2x will be, sine x period is 2 pi by 2, which is pi. The same way, if fx has period p, then the function x by a has period a times p. So if we are having a function sine x by 2, it is periodic with period 4 pi. Now what is trigonometric series? Any series of the form a0 by 2 plus summation n varying from 1 to infinity an cos nx plus bn sin nx is called trigonometric series, where a0, ans, bns, these are the coefficients. They may be constants, right? So this is a trigonometric series. So any series in the terms of sines and cosines is a trigonometric series. Okay. If our function is periodic with period 2 pi and integrable, then we can find out the values of a0, ans and bns, and we can obtain a series which is called Fourier series, and these coefficients are called a0, ans and bns are called Fourier coefficients. So how to evaluate these values a0, ans and bns? Now just see, we are given a function which is periodic with period 2 pi. It is defined on the interval either minus pi to pi or 0 to 2 pi. Period will be evaluated from the interval's length, that is 2 pi minus 0 or pi minus minus pi, which will become 2 pi. So by finding the length of interval, we will get the period of the function. Okay, so our function is defined on this interval minus pi to pi. So that means this function is periodic with period 2 pi, and given that this function is integrable, so we can evaluate the value of a0, an and bn. Now just see how. Now in this equation, if you integrate both side, left side as well as right side, from minus pi to pi. What we will see, this is integration minus pi to pi fx dx is equal to a naught by 2 integration of 1 from minus pi to pi with respect to x plus summation n varying from 1 to infinity an integration minus pi to pi cos n x dx plus bn integration minus pi to pi sin n x dx. Okay, so this integration is 0. Why? What is the integration of cos nx? It will be sin nx by n. And when you substitute the limits minus pi to pi, it will be 0. The same way, when you integrate sin nx with respect to x, this is minus cos nx by n. And again, when you substitute the limits minus pi to plus pi, this value is 0. So this is 0, this is 0. We left with only a naught by 2 into integration of 1. What is integration of 1 from minus pi to pi? It is 2 pi. So 2 will be cancelled out. We left with a naught into pi is equal to integration of fx from minus pi to pi. So what will be the value of a naught? A naught will be, you take pi to be this side, we will get a naught will be 1 over pi minus pi to pi fx dx. So in this way we can find out the value of the coefficient a naught. Okay, next we will find out the value of an. Now how to find the value of an? Now we multiply this whole equation with cos nx. So fx into cos nx, a naught into cos nx, an into cos square nx plus bn into sin nx into cos nx, and then integrate minus pi to pi both sides. Now in this time our a naught into integration of cos nx is 0, right? Bn sin nx into cos nx, multiply by 2 and divide by 2, you will get 2 sin nx into cos nx. Find out the integration of this. This is also 0. We left with only this term an cos nx into cos nx and integrate it from minus pi to pi. This value will comes out to be pi. So now we will get the value of an only. So what will be an? It will be 1 over pi minus pi to pi integrate fx into cos nx. Similarly, we can find out the value of bn. First we multiply this equation by sin nx and then you integrate minus pi to pi, you will get the value of bn. Okay, so these are called the Fourier coefficients or Euler's formula, right? So in case we have to find the value of, we have to obtain the Fourier series of this function, means we have to find the values of a naught, ans and bns. So remember only these formulas. Just apply these formulas. Find out the values of a naught, ans and bns. Substitute over here. You will obtain the Fourier series of any function fx. Okay. Now this is the next case when our function is defined on the interval minus L to L. Here it is defined on minus pi to pi. Then our series is of form this. But when our function is defined on interval minus L to L with period 2L. 2L is what? The length of this interval. Okay. So 2L is the period of this function and our function is defined on minus L to L. Then the form is f of x is equivalent to a naught by 2 plus summation n varying from 1 to infinity an cos n pi x by L plus bn sin n pi x by L. Now just see, if here our L is pi, you will substitute the value of L over here, you will get again nx, the same form, right? So this is more general form than this case. Okay, so this is the Fourier series. And now why I have used the symbol equivalent over here, because in the left hand side we have a function and on the right hand side we have a series. Okay, so series is not always converging to same function fx, so that's why we have used the symbol equivalence over here, right? So once again, see, fx is periodic function defined on the interval minus L to L, then its Fourier series will be of the form this one, and we have to obtain the values of a naught, ans and bns. We have to find the values of a naught, ans and bns, and these are evaluated by using these formulas. A naught is equal to 1 over half of the period. Same way here, 1 over half of the period. Here the interval is minus pi to pi. Here the interval is minus L to L. So A naught will be 1 over L, integration of the function fx from minus L to L. Okay. Similarly, an is 1 over half of the period, integration minus L to L, fx cos n pi x by L. And the same way bn, 1 over L minus L to L, fx sine n pi x by L. Now the next case, this is more general than previous one. Now our function is defined on any interval AB with period B minus A. B minus A is what? Nothing but the length of this interval. Okay. Then the Fourier series of this function is of the form a naught by 2 plus summation an cos 2n pi x by b minus a, which is same as that this n pi x upon half of the period. Here n pi x upon L, which is half of the period. N pi x upon half of the period b minus a by 2. So 2 ऊपर चला गया आपका. Okay, so you will get a naught cos 2n pi x by b minus a. The same way sine 2n pi x by b minus a. Right? Again, the values of coefficients are a naught is equal to 1 over half of the period, so that is 2 by b minus a, integration from the interval a to b fx dx, and same way an and bn's. So if we have to obtain the Fourier series of any periodic function, we have to find out the values of a naught, ans and bn's. Find out first the values of a naught, ans and bn's and substitute over here. We will get the Fourier series expansion of the function fx. For example, find the Fourier series expansion of periodic function fx is equal to x over the interval minus pi to pi, and here the function is periodic with period 2 pi, which is nothing but the length of this interval. Now just see, since x is not periodic, but here the function is defined over the interval this, and given that this function is periodic, it means it is repeated after 2 pi. So function will be like this. From minus pi to pi its value is x. From pi to 3 pi value is again x. From 3 pi to 5 pi again x, and similarly this side. So we have to obtain the Fourier series of this function, and our interval is minus pi to pi, so series will be of form this. It is a naught by 2 plus summation n going from 1 to infinity an cos n x plus bn sin n x. Value of a naught will be 1 over pi integration minus pi to pi x. X क्या है? What is x over here? It is nothing but the function. So integration of fx from minus pi to pi dx. So we get the value is 0. Now an, again 1 over pi minus pi to pi integrate करो x into cos nx dx को. right? Since we know that the integration of odd function from minus a to a is 0, now just see, x is odd, cosine x is even, odd into even is odd function, so integration of this will be 0. Similarly, find out the value of bn, it is 1 over half of the period, integration of x sine nx from minus pi to pi. Since this is even function, x is odd, sine is odd, so odd into odd is even. So we have to integrate this even function from minus a to a, and that will be twice time the integration of 0 to pi. So integration by parts, we will get the value of bn, this is nothing, minus 2 cos n pi by n, where cos of n pi is minus 1 to the power n, one more negative over here, so it will become minus 1 to the power n plus 1 by n. So the value of a0 is 0, an is 0, and bn is this much. Now you substitute the value of a0, an, and bn in this series. So after substituting these values, we will get this is the Fourier series expansion of x. So what are the requirements for existence of Fourier series? First, it should be periodic, function should be periodic, and secondly, it should be integrable over the interval. Only then we can find out the values of a0, ans, and bns, and then we can write any function in the terms of infinite series of sines and cosines. Okay. One more example. Let fx is pi plus x from minus pi to 0 and 0 to pi its value is 0. And given that this function is periodic with period 2 pi, we have to obtain the Fourier series of this function on the interval minus pi to pi. So means we have to find out the values of a0, ans, and bns. Use these formulas, simplify the integrals, and find out the values of a0, ans, and bns. Substitute over here the value of a0, the value of an, and the value of bn, and we will get the Fourier series expansion of fx. One more example. Let our function is defined over the interval minus L to L, and here L is 2, and it is periodic with period 4. Again we have to find out the value of a0, ans, and bns by using the Fourier formulas. 1 over L minus L to L integration of fx, 1 over L integration of minus L to L fx into cos n pi x by L, and similarly for bn's. Now here in this case, integration will split into two parts. From minus 2 to 0, the value of function is 2 plus x, and from 0 to 2, the value of function is 2 minus x. Okay, so this will be an will be 1 over half of the period, which is 2. Integration minus 2 to 2 will be split into 2. Simplify these integrations, we will get the value of an, similarly get the value of bn, and substitute in the main series the value of a0, ans, and bn. We will get the Fourier series expansion of this function. Okay. Now the next is Fourier series expansion of even and odd functions. Now what do you mean by even function? If f of minus x is same as that fx over the domain, then we say our function is even. And if f of minus x is minus times f of x, then we say our function is odd function. So let's suppose our function is defined on the interval minus L to L with period 2L, and given that our function is even function. Now just see, in this case, Bn will be always 0. Why? The formula for Bn is what? It is 1 over L integration of my function fx into sine n pi x by L from minus L to L. Now given that function is even, but sine nx function is odd, so even into odd will become odd function. So when you integrate odd function from minus L to L, it will be 0. Okay, so whenever we are having even function on the interval minus L to L, then always bn's are 0, means sine terms are 0. So we will get only Fourier cosine series. Okay, so whenever function is even function, we will obtain only Fourier cosine series, right? Means we will get the values of a0 and an's. Bn's are always 0. No need to find out the value of bn's. Just find out the value of a0 and an. Substitute in the series, you will get the Fourier series. Okay. Similarly, if our function is odd function on the interval minus L to L, then integration of odd function from minus L to L will be 0, means a naughts are 0, an's are 0. However, bn's will become 1 over L integration of minus L to L fx into sine nx. Odd into odd will become even function. So integration of even function from minus L to L is same as that, twice time integration of this even function from 0 to L. So this is a new formula for the coefficient Bn. So whenever our function is odd function, we will obtain only Fourier sine series, means we will only find out the value of Bn. No need to find out the value of a0 and an's. Only find out the value of Bn's. Just substitute in the main series and you will get Fourier sine series. And the formula for this is 2 by L integration from 0 to L, not minus L to L, because we have used twice over here. Okay, so this is an example. For example, we have to obtain the Fourier series of x square over the interval minus 2 to 2. Clearly here the function is periodic with period the length of the interval, which is 4. Now since our function is even function, so clearly in this case bn's will be 0. We have to just find out the value of a0 and an. And that will be what? 1 by L integration of x square from minus L to L, which is same as that, twice time 1 over L integration of 0 to L x square. Okay, so we will get the value of a0 is this one. Same way you find out the value of an. Now substitute the value of an and a0 in the main series and you will get the Fourier cosine series of even function on the interval minus 2 to 2. Now the next is convergence of Fourier series. Let the function fx and its derivative function f dash x both are piecewise continuous on the interval minus L to L. Now why is the requirement of this piecewise continuous? As the requirement for the existence of Fourier series is function should be integrable. So if our function is continuous, we know that it is integrable. Even if our function is piecewise continuous, then also our function is integrable. So this is the least requirement, that function should be, at least it should be piecewise continuous. So let fx and f dash x be piecewise continuous on the interval minus L to L. Then the Fourier series of the function fx on this interval converges to same fx at the point of continuity, and at a point of discontinuity the Fourier series converges to the half of the left limit of the function plus right limit of the function. Now once again see, first of all, when the Fourier series is convergent, at least piecewise continuous, right? So at the point of continuity, our series converges to the same fx, and at a point of discontinuity, our series converges to the mean value of right and left limits of the function at the point of discontinuity, right? For example, find the Fourier series expansion of fx of this function and hence show that this series is converges to pi square by 8. The value of this is pi square by 8. Now in this case, first we obtain the Fourier series, means we have to find out the value of a0, an and bn. Substitute in the series, we will get the Fourier series expansion of this function. Okay, so this already done on page number 3 in example 2, that this is the Fourier series of fx. Now next we have to show that the series 1 plus 1 over 3 square plus 1 over 5 square is pi square by 8. Now just see, our function is piecewise continuous on the interval minus pi to pi. It is continuous on minus pi to 0. Its value is pi plus x, and from 0 to pi its value is 0. So our function is piecewise continuous. Break exists over 0. Okay. Now you find out the value of the function at 0. Since our function is not continuous at 0, so value of the function at 0 will be what? Find out the value of the function from left side at 0. Find the limit of the function whenever your x going from 0 to negative side. It will be pi plus x, which is pi. Same way, find out the right hand limit of the function at 0, which will be 0. Since these two are not same, so therefore our function is not continuous at 0. Okay. Now just see, over the right hand side we have a series and over left hand side we have a function. If we substitute x to be 0 in the right hand side, our series converges to f at 0 minus, that means left limit at 0 plus right limit at 0 divided by 2. It will converges to the mean of these values because our function is not continuous at 0. So it is not converging to the same value of the function at 0. It will converging to the function at 0 at the mean value. Okay, but if we consider any point from minus pi to 0 or 0 to pi, let's suppose pi by 2. So substitute x is equal to pi by 2 in the right hand side. Since our function is continuous at pi by 2, it converges to the value of the function at pi by 2. Just the value of the function at pi by 2 because our function is continuous at pi by 2. Okay. However, our function is not continuous at 0. That's why our right hand side, the series at 0 is converging to the mean value of the function at 0. The left limit plus the right limit divided by 2. Similarly at pi, the left limit at pi is 0. The right limit at pi is 2 pi. Now why it is 2 pi? Since our function is periodic function with period 2 pi, that means after 2 pi the function is repeating again. Okay, so after pi again our function attain the value pi plus x, and before pi the value of the function is 0. After pi its value is again pi plus x, means pi plus pi, which is 2 pi. Again the left limit is not same as that right limit, so that means our function is not continuous at pi. So again, if we put x to be pi in both the sides, our series is converging to the mean value of the left limit plus the right limit of the function at pi. The same way at x is equal to minus pi. Now at x is equal to minus pi, our function is continuous, so no problem. So substitute x is equal to minus pi in the right hand side, it will converging to the value of the function at minus pi, because our function is continuous at minus pi. Okay. Now since we have to show that 1 over 1 square plus 1 over 3 square plus 1 over 5 square and so on is pi square by 8, and the Fourier series is this much. Now just see, from this series we have to find 1 square, 3 square, 5 square. That will be come over here, not come over here. So clearly we have to substitute such value of x such that these terms are 0. And we know that sine x, sine 2x, sine 3x, they all are 0 at 0, pi, minus pi. So we can choose x to be 0, pi, minus pi. Okay. Next, all these terms are positive, right? So we have to choose such value of x such that these all terms remain positive. So that means x should be 0. If you take x to be pi, this value will be negative. Cos 3 pi, again the value is negative, and so on. Since we have to choose a positive value, so we consider x to be 0. Right? So we take x to be 0 in this series. So substitute the value 0, we get pi by 4 plus 2 by pi. The value of cos 0 is 1 over 1 square plus cos 3 0 is again 1 upon 3 square, and so on. And all these values are 0. Right? Now since function is not continuous at 0, so what will be the value of f0? In this case, this value will be the mean of left limit at 0 plus right limit at 0, right? So this value will be pi by 2. So substitute the value of f0 to be pi by 2 over here. Now just simplify this. We will get 1 plus 1 over 3 square plus 1 over 5 square is nothing, pi square by 8. And this is we have to show. So clear everyone? Once again see, first we have to obtain the Fourier series of the function, and this is this one. Next we have to show this series. So on comparison we get it should be some value of x like 0, pi, minus pi, only then these terms will be 0. So we choose x to be 0 over here, we will get this series, right? Just simplify this, find out the value of f of 0. Now since our function is not continuous at 0, so we will take the value of f of 0, which will be the mean of left limit at 0 and right limit at 0. Substitute the value over here, simplify this, we will get this. Okay, more questions can be done from the tute sheet. Now the next topic, that is half range Fourier cosine and Fourier sine series. Now in this case, again our function is at least piecewise continuous, and it is defined on half range, not minus L to L, it is defined on 0 to L. But the period is 2L. So our function is given to us only on the half range. We have to extend the function in such a way Either the function becomes even or function becomes odd. Once again see, in this case our function is periodic with period 2L, but it is defined on half range. We have to extend the interval minus L to 0. So we have to define the value of the function on the interval minus L to 0. In two ways we can define the value of this function. Either we can make the function to be even. So we can extend the function from minus L to 0 in such a way so that our function is even, or we can extend the function to be odd by defining in such a way. As in the previous slides we have already done, whenever our function is even we will get only cosine series. Whenever our function is odd we will get only sine series. Okay, so if the question is find out half range Fourier cosine series, means we have extended the function in such a way so that it becomes even. Okay, so in case of even function, bn's will be 0, we get only a0 and an's. So we will get only Fourier cosine series. For example, if we have to find the half range Fourier cosine series of the function 1 from the interval 0 to 2, means we have to obtain the values of only a0 and an's. So the value of a0 will be 1 over half of the period integration minus L to L. But in this case our function is defined 0 to L. So we will write the formula twice time of this from 0 to L because our function is even function. Okay. So directly we write the value of a0 to be twice 2 by L integration from 0 to L fx dx. Just simplify this, we will get the value of a0. The same way find out the value of an, it will be twice time 1 over L integration 0 to L fx cos n pi x by L. Substitute the values over here. The value of L is 2. Substitute over here, simplify this integral and we will get the value of an. No need to find out the value of bn because we have to obtain Fourier cosine series. So bn's are always 0 in this case. Now just substitute the value of a0 and an in the series. We will get the Fourier cosine series of 1 over the interval 0 to 2. So what are the formulas? The formulas are, in case of half range Fourier cosine series, the value of a0 is 2 by L 0 to L fx dx. The value of an is 2 by L 0 to L fx cos n pi x by L. And the series is only cosine series. Similarly, half range Fourier sine series formulas are bn's is 2 by L 0 to L fx sin n pi x by L, and the series is only sine series because in case of half range Fourier sine series we have extended the function in such a way so that function is odd. And if our function is odd function, we will get only Fourier sine series. A0 and an's will be 0. We have to find only the values of bn. No need to find a0 and an. Just substitute the value of function over here. Integrate this, we will get the value of bn. Substitute over here, we will get the Fourier sine series. For example, obtain half range Fourier sine series of same fx is equal to 1 on the interval 0 to 2. Means we have to find out the value of only bn. So what will be the value of bn? it is twice time 1 over L. The value of L is 2. Integration of 1 into sine n pi x by 2 from 0 to 2. We get this value. So substitute over here in the series. So this is the half range Fourier sine series of the function fx, which is 1. Thanks. In the next video, I will teach you the application of Fourier series.